Right, so Simpson's rule. This uses parabolic arcs. Okay, so arcs of a parabola to estimate the area underneath a curve instead of straight line. Okay, so generally speaking, not always, will provide a better estimate for the area when compared to trapezoidal rule. Okay, so in other words, you've got some function of x between A and B. Okay, and we want to find the area underneath the curve. Alright, Simpson's rule allows us to create an arc. Okay, so we get halfway between. And any 3 points will always form at least a parabolic arc or an elliptical arc. Alright, so in other words, if I join an arc best I can through 3 points, like that, that's pretty good. Alright, if I do the arc that goes through 3 specific points, alright, generally speaking, that arc and the area underneath it will provide a much better estimation of the area compared to rectangles and also compared to trapezoidal rule. Alright, so a parabola is drawn through 3 equally spacing points. So, the integral, we're all going to get very, well, some more than others. Alright, going to get very good at that symbol. From B to A of your f of x dx, remember this is still an approximation. Alright, it's equal to B, take away A on 2, f of A plus 4 times the function of f of A plus B on 2. So the midpoint, okay, this is f of A here, f of A plus B on 2, and we need to multiply that by 4. And f of B.
Is that plus that thing?
So,
Yeah. Plus that.
yep. Now, so whatever the function of A plus B over 2, the midpoint between your endpoint, you then need to multiply by 4, okay? Remember one very good lesson when I had the HC class 2 years ago, that they kept putting that 4 inside the function. Okay, if I put that 4 in the function, there'd be no point in having this 2, right? Because I could simplify the 4 over 2 and just be 2 outside of A plus B. Okay, so this 4 stays outside, you do the function of the midpoint, and then you multiply it by 4. Okay, so one application uses 3 subintervals, functional values, or ordinates. Okay, so subintervals I'm going to use for the moment. So technically you need 2 because you're doing the average, but just to illustrate, you need 3 values here to be able to use one application of Simpson's rule. And just like trapezoidal, you can have more than one application, so it can ask you to do 2. I wouldn't imagine they'll ask you any more than 3. And if they do ask you 3, that's pretty a bit mean. Okay, so n application uses 2n plus 1 subintervals. Okay, so 2 application, 2 times 2, which is 4, plus 1, you need 5 functional values. 1, 2, 3, 4, 5. Okay? So you only need 2 for one application of trapezoidal rule, you need 3 for one application of Simpson's rule. Alright, example. So we're going to cover the first example we did yesterday on the trapezoidal rule for finding the area for the parabola between 3 and 1, and we're going to see how our approximation compares. So, example A, find an approximation for integral from 3 to 1 of our x squared dx. Right, you always sketch the area to be found. Let's get in the good habits now, because that will be significant for a couple of other things you need to work out later on. Okay, so from 3 to 1, so we only need the first quadrant because both the x values are positive. You're going to draw the parabola in the first quadrant. Okay, from 1 to 3. Okay, so we are finding that area. Alright, so what we need to do is include that midpoint. And what we're finding is the area of the parabolic arc that goes through those 3 points. This one's not very well drawn, but you can always parabolic arc through any 3 points. Okay? Alright, so what's halfway between 1 and 3? 2. Alright? So instead of substituting 1 and 3 divided by 2, just use your common sense and put in f of 2. Alright? So the integral from 3 to 1 of x squared dx is approximately equal to, what's b and a?
3 and 1.
3 and 1. Okay, the endpoint of the Simpsons, the parabolic arc you're doing, the 3, take away 1 over 6. 6. Write down the wrong formula.
6, yeah, it'll be 6.
Yeah, right, 3 over 6.
Ah.
Right, so proof, so the reason why I haven't proved it is a lot more complicated, even for you extension 1 students.
What about extension 2 students?
Same students.
Okay, so f of a, so if f of x, remember, is the functional value here, x squared, so we're going to do f of 1 plus 4 lots of f of 2. So instead of writing a plus b over 2, I'm just using my common sense that 2 is halfway between 1 and 3, and I'm going to calculate f of 2. Okay, plus f of 3. Right, 3 take away 1 is 2. So a third. Alright, so if f of x is x squared, f of 1 is going to be 1 squared plus 4 lots of f of 2. So f of 2 is going to be 2 squared, and f of 3 is going to be 3 squared. Okay, remember we need to multiply that middle term by 4. So approximately equal to a third. 1, 4 to the power 3, 4 times 4 to the power 2 is 16, 17 plus 9. Okay, 26, so 30, 26. Okay, so we can write it as a proper, a mixed, or an improper. Okay, in most cases they're going to accept improper anyway. And don't forget your units squared. So yesterday we did the same question using the trapezoidal rule. What did we get yesterday?
Like, was it 69 over 28? That was a different one. That's a different one. Yeah, this is always slow.
Integral for x squared from 3 to 1.
Did we do
10 units.
10 units. 10 units.
And it's squared.
So that was over 2.
Okay, because remember it can have a significant part of the trapezium sticking up out above the curve.
So what is the red bit? Is that just another,
Sorry,
What we're measuring. Like,
the second red line is what we're,
this one,
no, the, yeah.
that's the parabolic arc through the 3 points.
I don't know how I'm supposed to
Would it be
You don't need to.
concave?
That's not very well drawn, but if you pick any 3 point, okay, you can always draw a parabolic arc through them.
do it.
Exactly.
Pretty terrible. Don't you ever mock me in my classroom again.
Or what?
Alright.
It's not 8S. The door got opened halfway. We didn't see who it was. It said it's not 8S, and the door just slammed.
Ah, Pembroke Alright. B.
Hey!
Who was it?
Mr. Wall. I think he's looking at. He must be looking for 8S.
Okay, use two applications to find the approximation for the integral from 5 to 1 of -2 to the power of x dx. Now this comes under other graphs in your chapter 5 functions and graphs.
Log is the
Oh, chapter 5. That's the exercise I read to start today.
Oh, so you should be reasonably fresh with what this looks like. Are you even up to this one yet? 5 to 1. Okay, so this graph's going to be below the x-axis. Alright, and we're going to have sort of like a hyperbola, not quite, from 1 to 5, using two applications.
Oh, I did it upside down.
Oh. Sure you did it. Is that how they make bridges?
Make what?
Bridges.
Bridges.
Bridge?
Oh, it could be an application. More like a stuntman's epic motorbike.
oh, it's a fail.
Like-
You're going. Damn.
Okay, two applications. Right, so in other words, 2 to the power of x is what's called an exponential. Goes like that. Alright, so -2 to the power of x is a reflection on the x-axis. Okay, we all. Right, so we need two applications. So we need to determine what values we're going to need. Alright, so one application, you need that midpoint. Okay, so what's halfway between 1 and 5? 3. Okay, so don't need to go ahead and substitute 1 plus 5 over 2. Don't need to do that. That's of course one application. Right, so you need two application. So two application, 2 times 2 plus 1 intervals. Okay, I've got 3, so I need another 2.
0 and 6.
What?
I want 0 and 6.
Oh,
Wait, no,
No.
that's not semi-area. What am I talking about?
What are you talking about?
That's 2 and 4.
Okay, so remembering we are finding the area between 5 and 1. Okay, so there's my endpoint there. I've got the midpoint, and I've also got the midpoint between the midpoint and the endpoint.
The quarter point. The
Okay,
midpoint.
so that's what I need to do. So, two application, I'm actually going to write this out twice. Alright, just to save myself that confusion. So, the integral from 5 to 1 of -2 to the power of x dx is approximately, alright, make sure you have your notation correct, because if you don't write equal, they'll be going like that, and then you get something else. No, sorry, I don't know what you're talking about. Okay, so make sure you have these things down pat. Okay, so is equal to b, take away a over 6, so write down your formula so that you learn it. F of a plus 4 times the midpoint plus f of b. Okay, what is the value for a and b if I use the first application?
Oh no, I did it wrong.
The first application, you need 2 of them.
1 and 3.
Okay, so we're using 2 applications, so we're splitting this up into 2 parabolic arcs, here and here. Alright, so that's going to be your A, and that's going to be your B for the first application. Alright? For the second application, that's going to be your A, and that's going to be your B.
Do we label it as first application?
Don't need to. Alright, so it's approximately equal to 3, take away 1 on 6. Now, watching your signs here. It is a negative of 2 to the power of x. So in other words, it's negative 1 times 2 to the power of x. Okay, it is not negative 2 or to the power of x. That's two different things. Alright? So we need f of a, so we need f of 1, so negative 2 to the power of 1, plus 4 times the midpoint between 3 and 1, which is 2. So I need to substitute 2 in there. Remember, your f of x is negative 2 to the power of x. Okay, 4 times negative 2 to the power of 2, plus f of b, b is 3, so we're going to have negative 2 to the power of 3. Right, that's one application. So now you need to rewrite this again with the changes in your A and B, and also that midpoint will also change. So plus, so now B is 5, A is 3. So this number out the front will be the same, okay, because we are evenly spaced on either side. So negative 2 to the power of 3. So now we're doing 3, 4 and 5. Plus 4 times negative 2 to the power of 4. Plus a negative 2 to the power of negative 5. Alright, so after you showed me the evidence that you've understood the substitution you're working, now's the point you can go to your calculators and put that expression in. Tell me what you get. In the exact form.
There's a negative 5 or positive 5?
Oh, sorry. Yep. Thank you. Just positive 5 there. I don't know why I wrote negative. We've got talking about negatives.
It's probably after you wrote
Okay, I got all of the basic questions of this, but
Yep.
as we went into the negatives, something's lost me and I don't understand where's the negatives.
Because the actual function itself is a negative. Okay?
So f of x is minus 2.
So when you have f of 1, you replace x with 1. So negative 2 to the power of 1. Alright, so f of 3,
So it just becomes a power.
because x is in the power. 2 to the power of 3. And so forth.
Right. Thank you.
That's right. That's what I do.
Oh, hurry up, Robin.
At least you've got a calculator.
I do have it, I just didn't bring it. Because I don't have a bag.
You're gonna get another bag.
Yeah, but... I don't know.
10.
Got an answer.
Units squared.
Sure?
10. Spot on.
10?
Are you sure?
I got 10.
Are you positive?
I got 10.
Let's
You cannot have possibly got 10.
I got 10.
just double check that one.
Oh wait, I did 1 over 3, not 2 over 3. Haha.
Good one.
Oh.
How's it 2 over?
It is 1 over 3.
Yeah.
I got 10. I got 10.
Negative.
Spot on 10.
Okay, you're about to witness me just slap Robin.
Because I did it all outside the black. Yeah, I did it wrong. I put, yeah. You know what it is. I accept it.
What did I say at the start of the question?
I don't know.
Negative 2 to the power of 1 is squared through is different to negative 2 or to the power of 2.
So we're not putting the brackets.
No, you put,
Oh, okay. Well, it would have been nice if we had 10. That would have been nice. What would we do about
it'll be close to 10.
Assuming Robin hasn't stuffed that one up again. Hey?
Close to negative.
Negative.
Oh, I've got the first half.
Yeah.
Yes.
It'll be close to negative 10.
Okay, there's a difference between this and this. This is always what? Negative a to the x is always
Positive.
negative.
Negative.
The other one.
And a to the x is always, hang on, negative a to the x.
Usually positive.
Not always though.
Unless it's 3.
Okay.
Most cases, more cases positive. Okay, so for example you have minus 1 to the power of 3, still minus 1. Or to the power of 3.
I have to still want it. That's not the hot dog. Hang on,
What did you get in the top?
1697 out of 48. 35.
I'm gonna heckle Ruben.
No, because I wanted to run the boost as well.
As I took that photo, I wrote down
That'll work.
fashion. I'll leave the fashion. Stop it.
Dude, that's not
That's right.
Certainly more in line with the answer I'm expecting.
Holy, hey Robin. 10.
I would have preferred 10. Can we make that into a bracket and then make it 10? That would be.
I would have preferred you to be right the first time.
Hey, can we like make up our own theory where it ends up?
Yeah.
Not how this works.
Can we just make up a
Not how this works,
we'll
Amanda.
get a doctorate by saying everything in the world is 10.
It's not how this works.
Or we just kill everyone that has any knowledge about that and just say everything's 10. Yes, exactly.
Just kill like everyone except children.
1
Except
plus
children.
1.
Right,
And voters.
let's assume that we have the correct answer there.
I think so much more.
Does this answer make sense from what we're trying to do?
Negative area.
No.
So it has to be positive 1,697 over 48 units.
Yeah, but why are we getting a negative answer?
Because it's
And
underneath.
you're yeah.
Okay, so one of the things we will be doing this topic as well is considering what happened when the curve is above in the positive y direction and what's happening with the curve below the y direction. Okay? So approximately equal to 1697 on 48 units squared since bonding area. Yep. So in other words, if you're getting a negative value for your area, we need to take the absolute value of it because area is always represented as a
Shouldn't that be in
positive
the
quantity.
formula then?
Huh?
That should be in the formula then. Absolute value or B take away A.
So we could probably should have done this. That. Yep. Alright, last one for this section. C. Use the values in the table below to find an approximation for 4 to 1 f of x dx. So x, f of x, 1, 1.5, 2, 2.5, 3, 3.5 and 4.
Wait, what?
Alright, 12.3, 14.2, 18.8, 16.5, 13.0, 19.1 and 20.8.
Oh my gosh. Why am I doing this?
Did you know that in the general course they do this as well?
I know how to solve this. bloody easy. Bloody easy.
But is that a 13.0?
Although their formula is slightly different.
That's 13.0? Yeah.
Sure is.
Can we invite one of them? Just like a single general mathematics student, like extension 2 class. Just show them.
Hey, you want to go
I
to
didn't know-
grab one of my year 8 students.
I didn't know you were writing it like that, so I went a bit far.
Okay, so how many times I'm going to apply this rule?
Once.
3.5 times.
Just one? So if I'm given all these values in the table, they're just going to go to waste if I only do it three times. Okay?
2n plus 1.
So that, and that. Yeah? Now, the good thing about this question is I've already told you what f of x is equal.
Nice.
Right? So you don't have to just fiddle around with the formula, you're just putting calculation in one decimal place. Okay, so integral from 4 to 1 of f of x dx is approximately equal to b take away a over 6 f of a plus 4 lots of f of a plus b over 2 plus f of b. Okay, so one application uses 3 functional values. So you're going to do this, then this, then this. Okay, so in other words, they share an endpoint. Alright, so B is 2, A is 1. So we've got 2, take away 1 on 6. F of 1, I'm told in the table what it is, 12.3. Plus 4 times the middle. Okay, and do that another 2 times with the base. No negative signs whatsoever except for subtraction.
What?
Plus, so now it's A, that's B, that's A. So it'd be 3, take away 2 on 6. 18.8 plus 4, lots of 16.5 plus 13.0 plus 4, take away 3 on 6. 13.0 plus 4, lots of 19.1 plus 20.8. Okay, and that's what I'm saying. It's going to be pretty mean for someone to ask you to do 3 applications.
Shorty not.
Alright? Unless they give you the values already.
We should take a like calculator and the ability where you take a photo of the equation. There's an app for that. Is there actually?
Yes.
That's really cool.
It doesn't so it works that well.
I don't think it works on the board, like, that's like textbook typed out.
Yeah, it's not that great.
It's not bad. Like the whole
Photo math.
use it. How much did it cost? Right on close to.
He's lying to me.
Having fun?
I think we can do one of
Vanessa?
5 minus 3. Z plus 1.
So these exercises will be very good. Make sure that your syntax and your calculators matches the answers that you should be getting.
Approximately 2959 60.
Okay?
approximately 295 /60.
Alright, approximately equal to 2959 over 60. Units squared. Okay, so you'll be able to find out if you're right or wrong how to use your calculator as you're going through the exercises.
So, when you involve what's that stick? Good fun, basic.
Okay, so I'm not going to get this section done today, so we'll get a start on it and we'll finish up on Thursday. Okay.
Just do